What is a decentralized exchange, or DEX? A decentralized exchange is a type of cryptocurrency exchange that operates without a central authority. To understand DEXs, let's compare them with traditional centralized exchanges like Coinbase or Binance. In a centralized exchange, users deposit their funds into the exchange's wallets. The exchange acts as an intermediary, holding user funds and personal information. In contrast, a decentralized exchange operates without a central authority. Instead, DEXs use smart contracts on blockchain networks to facilitate peer-to-peer trading directly between users' wallets. This peer-to-peer structure provides several key benefits that are driving the growing popularity of decentralized exchanges. First, DEXs give users full control over their assets at all times. Your tokens remain in your own wallet until a trade is executed. Second, DEXs enhance privacy by not requiring personal information or KYC verification. Users can trade anonymously using only their wallet addresses. Third, DEXs reduce counterparty risk. Since there's no central entity holding your funds, there's no risk of the exchange being hacked or becoming insolvent. Finally, DEXs offer global accessibility. Anyone with an internet connection and a compatible wallet can access these exchanges, regardless of location or status.
Smart contracts are the backbone of decentralized exchanges. They are self-executing programs stored on a blockchain that automatically run when predetermined conditions are met. In decentralized exchanges, smart contracts handle the entire trading process automatically. When a user initiates a trade, the smart contract contains code that automatically handles the verification and execution. The transaction process begins when a user initiates a trade. The smart contract first verifies all transaction parameters. Then it checks if both parties have sufficient funds for the trade. Finally, it executes the exchange atomically, meaning either the entire transaction completes successfully or it fails entirely. The atomic nature of smart contracts eliminates counterparty risk. Transactions are atomic, which means they either fully complete or entirely fail. This eliminates the risk of partial execution or one-sided transactions that could occur in traditional trading systems. Automated market makers, or AMMs, form the backbone of most modern decentralized exchanges. Unlike traditional exchanges that use order books to match buyers and sellers, AMMs use a completely different approach. Traditional order books require counterparties and can suffer from liquidity gaps. AMMs instead use liquidity pools and mathematical formulas to enable trading at any time without the need for matching counterparties. At the heart of AMMs are liquidity pools, pairs of tokens deposited by users called liquidity providers. AMMs use a mathematical formula to determine prices. The most common is the constant product formula, X times Y equals K. Let's see how trading works with AMMs. We'll start with a pool containing equal amounts of token A and token B. When a user wants to swap tokens, they add one token to the pool and receive the other. Let's say a user adds 10 token A. According to the constant product formula, adding token A will decrease the relative price of token A and increase the price of token B. The user receives approximately 9.1 token B in return, maintaining the constant product of 10,000. Price impact is a key concept in AMMs. As traders add more of one token, the price shifts along a curve defined by the constant product formula. The price always follows this hyperbolic curve, where X times Y equals K. Larger trades move further along the curve, resulting in higher slippage. Several popular decentralized exchanges use AMM technology. Uniswap pioneered the space on Ethereum, while SushiSwap expanded the model across multiple chains. PancakeSwap brought AMMs to Binance Smart Chain with lower transaction fees. These AM-based DEXs have revolutionized decentralized trading by providing continuous liquidity and eliminating the need for order books. Liquidity pools are the backbone of automated market maker-based decentralized exchanges. A liquidity pool is a smart contract containing a pair of tokens, like Ethereum and Bitcoin. Initially, the pool is empty, with no tokens available for trading. Liquidity providers are users who deposit an equal value of 2 tokens into the pool. When they deposit tokens, equal monetary values of each token are added to the pool. In return for providing liquidity, they receive LP tokens. These tokens represent their share of the pool. LP tokens entitle holders to a portion of the trading fees generated by the pool. When traders use the pool to swap tokens, they pay a small fee. For example, when someone swaps 1 ETH for BTC, the pool now contains more ETH and less BTC. The trader receives Bitcoin in return, with the exchange rate determined by the constant product formula. Each trade incurs a fee, typically 0.3% of the transaction amount. These fees are distributed proportionally to all liquidity providers based on their share of the pool. For example, a provider with 60% of the pool receives 60% of the fees, creating a passive income opportunity. To summarize, liquidity pools require providers to deposit equal values of token pairs. In return, they receive LP tokens representing their share of the pool. Trading fees, typically 0.3%, are distributed proportionally to all liquidity providers, creating a passive income opportunity. Liquidity pools are the foundation of AMM-based DEXs, enabling token swaps without traditional order books. Let's compare two fundamental models of decentralized exchanges: order book DEXs and automated market maker DEX. Order book DEXs like DYDX and IDEX use a traditional order matching system similar to centralized exchanges. In an order book model, traders submit buy and sell orders at specific prices. The exchange then matches these orders when prices overlap. On the other hand, automated market maker DEXs like Uniswap use liquidity pools and mathematical formulas instead of order books. AMMs rely on liquidity pools where tokens are pre-deposited. Prices are determined by a mathematical formula, typically X times Y equals K, creating a constant product curve. Both models have their own set of popular implementations. Let's examine the key differences between these two DEX models. Order book. DEXs often have fragmented liquidity as orders are spread across different price points, while AMMs provide liquidity at all prices through their pools. For price impact, order book DEXs typically offer better rates for large trades on liquid pairs, whereas AMs can experience significant slippage with larger transactions. Order book. DEXs support advanced trading features like limit orders and stop losses, while AMMs generally offer simple token swaps only. In terms of capital efficiency, order book DEXs typically perform better as liquidity providers can target specific price ranges. Each model faces different risks. Order book DEX are susceptible to front-running, while AMM liquidity providers face impermanent loss during volatile markets. Your choice between order book and AMM DEXs ultimately depends on your specific trading needs and prevailing market conditions. Order books excel in active liquid markets and for traders using advanced strategies, while AMMs are ideal for simple swaps and markets with less liquidity. Decentralized exchanges face significant challenges with blockchain limitations, particularly in transaction speed and costs. Traditional blockchains often suffer from congestion, resulting in high transaction fees and slow processing times. Cross-chain solutions like Thorchain address these limitations by enabling trading between different blockchains. For example, Thorchain allows users to swap Bitcoin directly for Ethereum without requiring wrapped tokens or centralized intermediaries. Layer 2 solutions like Optimism and Arbitrum build on top of existing blockchains to increase transaction throughput and reduce fees. These solutions work by batching multiple transactions together before submitting them to the main blockchain, significantly improving efficiency. These technologies provide three key benefits for decentralized exchanges. First, significantly higher transaction speeds, allowing thousands of trades per second. Second, dramatically lower fees, making DEXs more accessible for traders of all sizes. And third, maintaining decentralization by inheriting security from the underlying blockchains. These technologies are crucial for scaling decentralized exchanges to handle higher trading volumes while maintaining the core principles of decentralization. While decentralized exchanges eliminate custodial risks, they introduce several important security considerations that users must understand. There are 4 main security risk categories to consider when using decentralized exchanges. Smart contract vulnerabilities represent one of the biggest risks in DeFi. Code flaws can lead to catastrophic fund losses when exploited by attackers. Even small coding errors or oversights can create exploitable vulnerabilities. Several high-profile incidents have resulted in millions of dollars of losses. Unlike centralized exchanges where the platform manages custody, with DEXs, users must secure their own private keys. This self-custody model eliminates the risk of exchange hacks, but transfers all security responsibility to users. This includes securely storing private keys, using hardware wallets, avoiding phishing attacks, and never sharing seed phrases. DEX trading introduces specific risks not found in traditional exchanges. Let's explore three important ones: slippage, front-running, and impermanent loss. Slippage occurs when large orders move the price during execution, resulting in a worse price than expected. Front-running happens when observers see your pending transaction and insert their own transaction ahead of yours to profit from your trade. Impermanent loss affects liquidity providers when token prices change relative to each other, potentially resulting in less value than simply holding the tokens. Unlike centralized exchanges, DEXs typically lack insurance funds to cover losses from security breaches or smart contract exploits. This fundamental difference means users bear full responsibility for their funds. When hacks occur on DEXs, users often have limited recourse for recovering their assets. To minimize risks when using decentralized exchanges, follow these security best practices to protect your assets. The future of decentralized trading is evolving rapidly, with innovations transforming how we interact with digital assets. Current innovations are dramatically changing how DEXs operate. Concentrated liquidity allows providers to focus capital in specific price ranges. Yield optimization platforms automatically maximize returns on idle assets. And integration with other DeFi protocols is creating robust financial ecosystems. Looking ahead, we can anticipate several key advancements in decentralized trading. Over the next few years, we'll likely see more efficient cross-chain trading, zero-knowledge technology for privacy, institutional-grade tools, AI-driven liquidity optimization, and significantly improved user interfaces. This evolution represents a fundamental shift in finance. We're moving from traditional hierarchical systems to networks where users maintain sovereignty over their assets. The key principles driving this transformation are transparency, censorship resistance, and reduced reliance on centralized intermediaries.